The sea, a vast, secure and sustainable resource of energy, underused and underexploited. Wave and tidal technologies are at the forefront of renewable energy development. And although there is a constantly replenished resource, it is yet to be fully exploited, as the technologies must overcome many challenges if they are to become economically viable. DNV-GL Renewables Advisory is the world's largest renewable energy consultancy. Dedicated to serving the renewables industry, they offer independent technical and engineering services, products and training to the wind, wave, tidal and solar sectors. With almost 30 years' experience, DNV-GL Renewables Advisory has an unsurpassed technical understanding of renewable energy technologies, projects and markets. With offices around the globe and a network of local experts providing informed perspectives, the company is uniquely placed to understand the interplay between technology, geography and environmental conditions, providing real added value to its clients. DNV-GL Renewables Advisory has acted as technical advisor on more wind energy financing than any other company. With dedicated teams at the forefront of research and development activity, they provide consultancy services in the wave and tidal market and have delivered the world's first wave energy converter and tidal turbine design software, Wavedyne and Tidal Bladed. DNV-GL Renewables Advisory's focus on the wave and tidal energy sector began in 2005 with the founding of the Marine Renewables Group. Their engineers work alongside key wave and tidal device project developers, and they help to spearhead the development of prototypes and demonstration projects, supporting device developers to move from concept to prototype. They provide installation services, technical due diligence for investors, site data analysis, and array design and construction optimization services to project developers. The world has a significant wave energy resource, which, if properly exploited, could contribute significantly to global energy requirements. Deployment of wave energy converters, or WECs, in pre-commercial arrays is starting to occur now, with many more planned for the coming years. However, there is a need to understand the issues involved and be able to quantify any potential impacts of WECs when operating in arrays. As arrays grow in size, there will be a requirement to carefully consider the planning and analysis of WEC arrays. This is where DNV-GL's WaveFarmer software can help. WaveFarmer is a single software tool that allows information from multiple sources to be loaded, simulated and explored. It can accurately calculate the annual energy yield, reducing uncertainty in the cost of energy calculations for technology and project developers, investors and other key stakeholders. Andrew Garrod has had over 30 years' experience in the renewable energy field.
WaveFarmer is a virtual wave farm. So you can imagine a wave farm in real life, devices being put into the sea, and what we're trying to do is to develop a tool which can predict exactly how all those devices will behave, both individually and collectively as a farm.
R.V. Ahilan, Director of Division at DNV-GL Energy Renewables Advisory, has been pivotal in the consultancy of the Perawatt project.
Once you put multiple devices, waves are reflected, diffracted from the single unit, and that can then affect the other units that are on location. So one of the key developments that we've made in WaveFarmer as part of the Perawatt project is the fact that we are able to calculate rigorously the interference effects between multiple devices, which is an absolutely essential part of being able to identify the energy production capability of a farm as opposed to a single device.
So it's a mathematical model turned into a computer model which allows you to do all the things that you could do very, very expensively in real life virtually on a computer. So it models all the different aspects of a real wave farm, but it does it in a computer rather than in the sea. And therefore, it's a lot cheaper and more cost effective, and allows us to look at lots of different variations of a farm. So maybe we want to look at the deployment of these devices in different ways, in different shapes, in different sizes, and we can do all of that computationally and therefore reduce the risks of full-scale deployment.
What we have seen from that validation is that the known diminishment of the energy prediction from an array as opposed to a single device was well predicted, very accurately predicted when compared to measurements. So we know that we have some good validation data.
Inputs like seabed elevation, WEC locations, wave inputs, site constraints, and WEC description can be loaded in a wide range of commonly used formats and coordinate systems. WaveFarmer can be used with any type of WEC, including attenuators, pitching flaps, and point absorbers. There is a link to the single WEC design tool, WaveDyn, as well as DNV-GL's wave climate analysis and processing tools. WaveDyn has been commercially available through DNV-GL since 2012 and was the first public outcome of the Perawatt project. Energy yield results are broken down graphically by device and sea state to allow in-depth analysis. The genetic algorithm optimization computes the best layout of WECs for you, maximizing yield subject to realistic constraints such as minimum spacing and inclusion or exclusion zones. Maps show geographical information transformed to a single coordinate system and overlaid with results such as modifications to the wave climate from the array. Further extensions and modules are being created as part of DNV-GL's ongoing development program. Tidal motion is predictable, offering both a renewable and dependable source of energy. Tidal is a thriving industry that could grow rapidly with investment over the coming decades. The tidal industry is at a point where demonstration farms are being planned. These farms mark the dawn of a new era of marine energy, and the industry now requires tools and standardized methods to help project developers and energy analysts plan arrays which will provide greater confidence to lenders and investors. As arrays grow, there will be a requirement to provide tools and methods that can model their interactions. This is where DNV-GL's TidalFarmer software can help. What is TidalFarmer? TidalFarmer is a software tool that allows a user to define inputs to plan and build an array of tidal stream turbines. It models the array interactions within the environment and can predict the potential energy yield, allowing users to quantify uncertainty and make informative investment in the tidal stream industry. But why do we need tools like TidalFarmer?
TidalFarmer works by setting up, first of all, a model of the individual device. So we have a device, one tidal turbine. And we understand how that works. And we put that in a tidal stream, so the water passes by the tidal turbine. But of course, if this is going to be something which is commercially attractive and is going to make a large-scale contribution to our energy mix, which I believe it will, then we're not really just interested in how a single tidal turbine works. If water flows past a tidal turbine, it comes to the turbine with kinetic energy, with energy by virtue of its motion. Energy is then extracted by the turbine, and the water has therefore to go slower when it's gone past. If you try to slow it down too much, then actually it looks like a blockage in the river or in the stream, whatever it is. And the water will just say, actually, I'm not going to come here anymore, I'm going to go somewhere else. So you have to be very careful that you don't try and extract too much energy so that the water says, yeah, I can find an easier route some other way. And that's the point of TidalFarmer.
What TidalFarmer does is that we are able to model the collection of turbines and figure out how to optimize their locations. Where we've been we've been focused in developing the TidalFarmer software is to try to account for that wake interaction effect, but actually make it possible in a practical timescale, as opposed to solving the question always from a fundamental perspective. So what we have done in the TidalFarmer is to take advantage of some of the fundamental calculations in their full detail and their full prediction, and then find the simplifications that then make it practically useful in our industry.
TidalFarmer has many features that help to accurately predict the performance of device arrays. This includes a recently developed three-dimensional wake model that allows a full realization of a wake downstream of devices. Information concerning tidal stream turbines within a project can be modified, such as the power curve, rotor diameter, and yaw strategy, to help evaluate turbine design concepts. Turbine wakes can be visualized, enabling regions of high velocity deficit to be identified. Graphing tools allow users to view the energy production per device, so that any issues can be identified and corrected. Fast engineering models enable quick design iterations and allow you to quantify the level of uncertainty in a tidal farm project. Maps showing geographical information allow for results to be overlaid, enabling users to explore the impact of an array. As energy demand rises and the problems associated with conventional generation become ever more apparent, we need to address the serious challenges facing our energy supply. So what does the future hold for the renewable marine energy industry?
We're at a turning point in our consideration of energy in general and renewables in particular. I think we're seeing all over the world now a reconsideration of the future energy policies, future energy investments.
It's always been man's desire to actually create or use energy that can be replenished as fast as they can use it. And this is where the renewable energy technologies beat everything else. That means taking advantage of every form of renewable energy technologies, and we have demonstrated in the last 2 to 3 decades how well the wind energy that we have on Earth can be mobilized for purposes of man.
So if we're looking at the future, we can look at a future with relying on fuels coming from unreliable places in Eastern Europe, in the Middle East, whose prices are increasing, or we can rely on our indigenous product, wind, German wind, Swedish wind, Moroccan wind, British wind. When it's on your land, it's your wind. Same thing with waves, same thing with tides. So they're your tides, they're your waves, they're your wind when they're in your country. So surely the right way forward is the national wind on national hills, creating national jobs and making national electricity. With a falling price, indigenous security, low impact on the environment, new jobs and a new industry, not relying on imported fuel from unreliable countries all over the world.
For further information, contact WaveFarmer at dnvgl.com or TidalFarmer at dnvgl.com.